The universe, as vast and ancient as it is, continues to surprise even the most seasoned scientists. Just when we think we've begun to understand the cosmos, a new observation reshapes our perception entirely. This time, the revelation comes from the James Webb Space Telescope, humanity's most advanced eye in space, and it's being taken seriously enough for a Nobel Prize-winning physicist to issue a public warning. Launched in December 2021, the JWST was designed to look deeper into space and further back in time than any telescope before it. Equipped with infrared instruments of unparalleled sensitivity, it has already captured the light of some of the earliest galaxies formed after the Big Bang. However, among its many successes, a new set of data has presented something far more enigmatic. Anomalies that defy the standard models of cosmology and challenge our assumptions about how the universe operates. The discovery began with what seemed like a routine observation. The telescope was surveying a region of deep space in the constellation of Sculptor, a zone chosen specifically because of its relative emptiness, ideal for peering deep into cosmic history. But instead of empty blackness punctuated by the occasional faint galaxy, the JWST captured several objects with properties that didn't align with any known category of celestial body. These objects appeared unusually redshifted, so much so that their light suggested they were older than the universe itself, or at least from a time that contradicts current cosmological timelines. Redshift, in basic terms, is the stretching of light to longer wavelengths as objects move away from us due to the expansion of the universe. The farther away an object is, the more redshifted its light becomes. But what happens when the redshift is too extreme? More extreme than the models allow. According to Dr. Eliana Morsky, a Nobel Laureate in physics and one of the advisors on the JWST interpretation team, the findings indicate either a fundamental flaw in our understanding of cosmological expansion or the presence of some previously unknown mechanism at work. What we're seeing, she said in a recent briefing, is either a breakdown of the LCDM model, the standard model of cosmology, or something so exotic that we haven't even theorized about it yet. LCDM, or lambda cold dark matter, is the prevailing model describing the evolution of the universe. It assumes the universe began with the Big Bang, is dominated by cold dark matter, and includes a cosmological constant, L, accounting for dark energy. This model has held up remarkably well over the years, predicting everything from the cosmic microwave background to the distribution of galaxies. But now, JWST's data is poking holes in some of its assumptions. Among the most perplexing discoveries is the detection of galaxies that appear to be fully mature, only a few 100 million years after the Big Bang. According to the LCDM model, galaxies should take billions of years to form and evolve into complex structures. Yet, JWST's imagery suggests otherwise. These early galaxies are not only in place, but display spiral arms, active star formation, and even evidence of supermassive black holes at their centers. This defies logic. The universe, in its first billion years, should have been a chaotic place dominated by gas clouds and proto-galaxies. How, then, could such complexity emerge so early? The Nobel Laureate further elaborated that this could mean the timeline of the universe is either incorrect or incomplete. Alternatively, the rate of cosmic expansion may not have been constant throughout time as previously thought. One hypothesis gaining traction among theorists is that the universe may have experienced an early phase of rapid structure formation, an unexpected era of accelerated galactic evolution that current models don't account for. In addition to galactic anomalies, the JWST also observed peculiar energy signatures, fluctuations in the background infrared radiation that don't correlate with any known source of light. Some scientists believe this could be evidence of decaying dark matter particles, while others suggest a completely unknown form of energy interacting with regular matter in subtle, almost undetectable ways. This ties directly into the problem of the Hubble tension, a growing discrepancy between different measurements of the universe's expansion rate. Measurements from nearby supernovae and galaxies yield a faster rate than those inferred from the cosmic microwave background radiation. JWST's findings may provide the missing link in this mystery, or perhaps widen the rift even further. Cosmologists are divided. Some argue that these are early misinterpretations of the telescope's capabilities, artifacts or biases in the data processing pipeline. Others are more cautious, suggesting we need more observations to confirm such profound claims. Yet others are convinced we're on the edge of a paradigm shift, similar to when Einstein's relativity displaced Newtonian physics as the dominant framework for understanding gravity. Dr. Morsky is among those advocating caution but also openness. If this is indeed a new chapter in our understanding of the cosmos, we must be prepared to rewrite large portions of our theoretical foundations, she said. But science demands rigor, and it also demands humility. We must first rule out all conventional explanations before we resort to the extraordinary. What makes this situation more intriguing is that JWST's data aligns with a small set of anomalous results from other observatories, including unexplained fluctuations detected by the Atacama Cosmology Telescope and unexpected gravitational lensing patterns recorded by the Euclid Space Telescope. When disparate instruments operating under different physical principles report overlapping anomalies, it becomes increasingly difficult to dismiss them as coincidental errors. Furthermore, theoretical physicists have long speculated about exotic phenomena like early dark energy, primordial black holes, or even extra dimensions influencing our observable universe. These were, until now, largely mathematical curiosities, ideas that lacked supporting evidence. But if JWST continues to deliver such disruptive data, these theories may soon transition from fringe to mainstream. The implications are staggering. If our models are wrong about the age or structure of the universe, everything from the fate of galaxies to the origin of life may need to be re-evaluated. Even more philosophically, it challenges the reliability of our ability to observe and infer the universe's history from light alone, a cornerstone of modern astronomy. Governments and scientific agencies around the world have already begun convening panels to study the implications of these findings. The European Space Agency, NASA, and institutions like CERN and the Max Planck Institute are collaborating on a unified response, aiming to cross-validate the data using a network of observatories. While the public fascination with space often centers around alien life or habitable exoplanets, the real mystery may lie in something far more foundational: the laws of physics themselves. If JWST has indeed detected evidence of unknown physics, this would mark a watershed moment in scientific history, on par with the Copernican revolution or the discovery of quantum mechanics. And yet, as always in science, patience is key. More data will come. More anomalies will be observed, scrutinized, and tested. Only with time, collaboration, and intellectual honesty can we hope to make sense of what JWST is showing us. For now, the universe remains more mysterious than we imagined. It is not just a vast expanse of stars and galaxies, but a living laboratory full of questions, contradictions, and revelations. And with each new observation, we are reminded of just how little we truly know.